So in this lesson, we're going to talk about summation notation. And if you look at what's in the box there, it does look a little crazy, a little overwhelming. But when you learn what the parts are, it's really not that bad. That giant E there, or sigma, it's Greek for sigma, that just means the sum. You actually could see this in other places like an Excel spreadsheet or whatever, but it means the sum of. So it's just saying take the sum. And then if you know what the smaller parts are, then it would make more sense. So this on the bottom is, it says I equals A. A is going to be some number. This is your starting number. Okay. And then the one on the top, the N, that's also going to be a number. And that is your ending number. Okay. And then you're going to see after the E something funny looking. It says the function of I. And what that is really is the rule. And you're going to add up from the beginning number to the end number following that rule. It will make more sense when I do it in a second. So I'm going to enlarge this a lot because I just don't want to cram anything in. So based on what I just told you, we're going to start with 3 and we are going to end with 5. And 2i is the rule. So whatever I is, we're going to multiply it by that. So this is how it works. I like to make a little chart. You can do it however you want, but I'm going to start with I. It's 3. My rule is 2i. So I'm going to do 2 times 3, and that gives me 6. Then I'm going to go ahead and do 4. So 2 times I, well, my I is now a 4. I'm going to plug that in, and I get an 8. Then I'm going to do a 5, do the same thing again, but my I is now a 5, and that's not I for imaginary, it's just an I. And that's going to give me a 10. So once I stop at 5 because 5 is my last number that it told me on top of the sigma to stop there. So what I now have to do is sigma means summation or adding. So I am going to take the numbers that I now have. So I have 6 plus 8 plus 10, and that equals 24. So the answer is 24. All right, looking at B, they're now using K instead of I. They're going to switch it up every time. So I'm going to start at -1 and end at 3, and K squared is my rule. So if you liked the chart, you can do that. So my K, I'm going to start with -1, and I'm going to go up to 3. The work I'm going to show is K squared, and let's see what we get. So I have -1 squared. Be careful there. It's 1. If you're going to put it in your calculator, make sure you put the parentheses. 0 squared is 0. 1 squared is 1. 2 squared is 4. 3 squared is 9. But I have to add them all. So 1 plus 0 plus 1 plus 4 plus 9 is 15. And then they start to look crazy, but we follow the same set of steps. So we're going to start with 1, we're going to end with 5, and this is my rule. Okay, so they're now using J. I'm starting with 1 and I'm going to go all the way up to 5. Okay, my rule is 3 times 2 to the power of J minus 1, and we'll see what we get. So I have 3 times 2, 1 minus 1. Do not do the 3 times the 2 first. Please don't do it. You have to do exponents first, so you're actually doing 2 to the power of 0 first, which is 1. When you multiply the 3 times 1, you get 3. So we're going to do that again, but instead I have 2 minus 1. I suggest you just put it in your calculator just like that, and you should get a 6. Do the same with the 3. Now, if you can do this without writing it down, or you're just plugging it along in your calculator, that's fine. You don't really need to show all these steps. I'm just doing it so you can see what's going on. So now I'm going to put in a 4. So really it's 4 to the power of 3, which is 8, times 3 is 24. And then when I do my 5, I get 48. So I'm going to do 3 plus 6 plus 12 plus 24 plus 48, and that gives me 93. All right, D. In my chart this time, I'm not going to show my work. I suggest you pause this if you want to try and work it out yourself, and you should since you're just learning this. I'm starting at 1 and I'm ending at 5. When I plug in a -1 to the power of 1, I get -1. When I plug in a 2, I get a 1. When I plug in a 3, I get a -1, a 1, and a -1. That is okay. It is not necessarily going to be a ascending sequence, okay? So I'm going to do -1 plus 1 plus -1 plus 1 plus -1. Watch your negatives, and you should end up with a -1. On E, it does look a little bit more complicated, so I will plug in the first one, but you'll get the idea. So my K, starting at 1, and I'm going to do 1 plus 2 times 1 minus 1. And really, I'm just going to put that whole thing in my calculator, and I get 1. And when I do a 2, I should get a 3. When I do a 3, I should get a 5 and then a 7. Please pause this to verify that I didn't make any mistakes, and then you can chat me if I did. And then when you add those all together, you should get 16. At first glance, F, the rule looks a little crazy because I have a K and an X. If you see the K is just the number we're going to use, but there is an X. So I am just going to show you the work. So I'm only going up to 3. And my rule is K times K plus 1 times X. So I'm going to plug in a 1 there, and when I simplify that, I get 1 times 2x, and that's 2x. I just happen to have x in my answer. So when I plug in a 2, I have 2 times 2 plus 1x, and that gives me 6x. When I plug in 3, I have 3 times 3 plus 1x, and that gives me 12x. So when I add them together, I have 2x plus 6x plus 12x, and they are all like terms, so I can just add them together and keep the x. I'm going to give you a second to do exercise 2 on your own. Take a second, write it out, do it, press pause, and then come back and see if you got the correct answer. And the answer that I got is choice 3. Did you get that? I hope so. Or I hope you're not going to run away if you didn't get it. Just stay close. We'll work on it. Okay. What I'm going to do is I'm going to make my chart. So I have 1, 2, 3, 4. My rule is 1 over I. So I'm going to do 1 over 1, 1 over 2, 1 over 3, 1 over 4. But remember, you then have to add them together. 1 over 1, which is just 1, plus 1/2, plus 1/3, plus 1/4. Now you can add these if you want on your own, but you do have to find an LCD. And quite honestly, you know, I mean, you can. Your LCD would be 12. But if you want to just plug that right into your calculator, it is answer 3. And if you did get it, good job. Number 3. Consider the sequence defined recursively by a of n equals a of or sub n minus 1 plus 2 times a sub n minus 2 equals, and my first term is 0, my second term is 1. Find the value of, and then they give us the summation. Okay, so there is actually 2 things going on here. We have a really crazy recursive formula, and we have the summation. I'm going to start with the summation first. So this is saying a sub I. Basically what it's saying is if I plug in 4, 5, 6, and 7, the rule is just a of 4, a sub 5, a sub 6, a sub 7, and they want you to add those together. The problem is you don't know what your 4th, 5th, 6th, and 7th term is from this recursive. So we have to find them using the recursive. Now, in order to find the 4th term, we need the 3rd term and the 2nd term. And we don't have any of that. We have the 1st and the 2nd term. So that's what we're going to do. So I'm going to start off by writing my first term is 0 and my second term is 1. Now let's break down this formula a little bit. This part right here, we all know that and should know that now as the term before. Plus 2, but then it's being multiplied by this funky looking thing where you see how it looks almost like the term before, but there's a minus 2 there. So this is 2 terms before. I'm just going to put terms before. So here's what I'm going to do to now find the 3rd term. So I need to take the term before, which is a 1, plus 2 times 2 terms before. Well, if a sub 2 is the term before, a sub 1 is 2 terms before. And that's going to give me 1. And notice how term 2 is 1, so is term 3. That is okay. Oopsies. Now, let's find the 4th term. So I need to do the term before, which is 1, times 2 times 2 terms before that, which is also a 1, it's just a different one. And when I multiply that together and add it together, I should get a 3. So now when I do the fifth term, I'm going to do the term before plus 2 times 2 terms before. Let me just write this over here so it's not confusing. So 2 terms before would be that second one there. And that's going to give me 5. Okay, we still got to find the 6th and 7th term. So the 6th term is the term before, plus 2 times 2 terms before would now be that 3, and that is going to give me 11. And now for the 7th term, I'm going to just move it down here. I'll erase it all in a minute. So I'm going to do the term before, which is 11, plus 2 times 2 terms before, which was the 5, and that's going to give me 21. Now, we have all of the terms figured out up until 7. So the next thing we need to do is actually do the summation. So the 4th term is equal to 3. The 5th term is equal to 5. The 6th term is equal to 11. And the 7th term is equal to 21. So I'm adding 3 plus 5 plus 11 plus 21. So I'm adding the 4th through the 7th term together, and I get 40. I'm going to skip ahead to exercise 5, and what they want us to do there is write the summation. So we're basically writing the equation. Now, this is a little bit more tricky than you would think because it's not just figuring out the pattern. In the summation, what's being added together is the output after the pattern was applied. So we have to figure out a couple of different things. Now, when writing a summation, the easy part is knowing that I have this, and they want us to use n as our index. So we know that we're dealing with our first term. 40 is the first term, but we don't write n equals 40, we write the first term. Now, what goes on top, we don't know. We definitely have the first term, the second term, and the third term listed. That negative 20 is the last term, but we don't know how many are in between. So we don't know for sure yet what to put on top. Now, when you figure out the pattern, could you figure that out if it's not too high? You could, and you might need to in some cases, but for now we're going to try and figure out the pattern. Now it looks to me, even though the numbers are going down, it's addition. So that tells me that it's going to be an arithmetic sequence because it's addition. Actually, it's really subtracting, but if I look from there to there and there to there, what am I doing? I'm subtracting 12. So that's an arithmetic sequence. And then the summation is we're adding all the sequences together. So I'm going to refer to my formula from my notes on the last page where we do the first term plus n minus 1d. So I need the first term, which we know is 40, and my d is negative 12. So when I plug that in, I get 40 plus n minus 1 times negative 12. Now, could you put that into the summation looking like that? You could, but for somebody who's trying to figure out a summation like you did on the first page, that's going to be really messy. So what I'm going to do is I'm going to simplify. I'm going to distribute that negative 12. So it's going to give me negative 12n plus 12. And then when I combine like terms, I end up with 52 minus 12n, or negative 12n plus 52, whatever you prefer. So that is what I'm going to write as my summation rule. Now the last part that we need is what goes on the top there. Well, you can do it two ways. I can continue the pattern and, hope that it's not such a high number. So I would go 28, 16, 4. When I subtract another 12 from that, I get negative 8. And when I subtract another 12 from that, I get negative 20. So I can, this is the first term, the second term, the third term, which we already knew, fourth, fifth, and sixth term. So I need a 6 on the top. So that is my final answer. All that work for this final answer here. Now, what would you do if, it was a number higher than 6, or you just felt like you just kept going in the pattern and you weren't getting there, or you just wanted to do it quickly? Well, I don't know the term, but I do know what the term is equal to. So I would actually use this formula and I would plug a negative 20 in there and figure out what the n is. We did do this in lesson 1. So when I minus 52 minus 52, that's going to give me a negative 72 equals negative 12n. Divide both sides by negative 12, and n equals 6. So you can do it this way. It doesn't really matter as long as you can show your work. Okay, for the next one, it's the same idea. I have to do a summation, so I can draw that. I know that my first term is there. It's a 1. And again, I have that dot, dot, dot. So I don't know how high I'm getting. Now the question is, what's my equation this time? Is this an arithmetic or geometric? Now you do have addition here, but if you look at my answers, they are fractions. So when they're fractions, that tells me that division is happening somewhere, or multiplying by a fraction is happening somewhere, which actually makes me think that it's a geometric. So I'm going to use that formula from our notes from yesterday. And it's times by the common ratio of n minus 1. Okay. Now my first term I need, and that's 1 over 25. Now, how am I getting from here to here? The addition is from the summation. It's not necessarily that we're adding them together, because it doesn't really make any sense. But what's the pattern? If I ignore the plus signs, what's the pattern? Well, that's a little tricky from 1/25 to 5th. I think I know what it is, but I'm not really sure. But let me go to the numbers that I do know. Well, how do I get from 1 to 5? Add 4, but that's not going to work. Multiply by 5. Well, does that work? And it does. So my R is multiply by 5. If I wasn't sure, I could divide backwards. I would do 5 divided by 1, 1 divided by 1/5, 1/5 divided by 1/25, and you should get 5 every single time. So I'm going to plug in to get my general formula. So 1/25 times 5 to the n minus 1. Now, I am going to write this in my summation, because that is what's happening. That's what I would use to get my first, second, third, fourth, and so on, those terms. Now the question is, what term is that 625? How many terms is it? So like I did earlier, I could keep multiplying each of these by 5, and see where I get. So this would be 25. 1, 2, 3, 4, 5. 25 times 5 is 125. If I multiply 125 by 5, I get 625. So how many terms is that? 1, 2, 3, 4, 5, 6, 7. So 7 is the last term. And that is my final answer there. Okay, on the next page, I'm going to move a little faster with C and D. It's the same thing. So if you don't want me to move faster, I suggest pausing this and trying it on your own. For C, I know that it's an arithmetic. The common difference is I'm adding 3 each time. So when I plug into the formula, and then when I simplify it, I get 3n minus 9. So I'm starting at the first term, and my rule is 3n minus 9, and the question is, where am I finishing? I can do it, I'll do it algebraically this time. You can just continue the pattern. 15 equals 3n minus 9, add 9, that gives me 24 equals 3n. So it is the 8th term. I would have put an 8 up there, and that is the final answer. On D, I have figured out that the pattern is multiply by a -3, which makes it a geometric series. My first term is -2, so I'm going to plug in a -2 times my common ratio of -3 and minus 1. So when I write my summation, I know I have my first term, and my rule is that. Now, which term is that -1458? That number looks quite large. It is an exponent, you know, it's up to you. You can keep multiplying by 3. If you do that, let's do it really quick. So we have -2. When we multiply that by 3, -3, we get 6. Which we knew. We multiply that by a -3, we get -18, which we knew. We multiply that by a -3, we get 54. Multiply that by a -3, we get -162. And I'm going to keep going. And there it is, the -1458. So that is the 7th term, so I need a 7 on the top. Now, what I didn't show in the last problem, so that's the final answer, is how to find that 7th term in a geometric. I kind of skipped over it if you're going to do it algebraically. I kind of skipped over it because it would require you to use a log. I am going to do it right now. If you feel like that's going to confuse you, just fast forward ahead to the next question. But for the rest of you, I'm going to show how you algebraically figure out that -1458, how you figure out that it is the 7th term. Okay, so I'm going to plug that -1458 into the left side. And the right side should stay the same. And now I'm going to solve for n. N is an exponent, which tells me at some point I'm using a log. In order to do that, I need to get my base alone. Do not multiply the -2 and the -3 together. Don't do it. -3 is the base, not the -2. So I need to divide both sides by -2 to get that base alone. Now the next thing I'm going to do is put this in log form. Now, if you remember, the way that we did it to be consistent was the answer was on the right. So I'm just reorganizing that so the answer is on the right side. And now I'm going to put it in log form. So log base -3 of 729 equals n minus 1. Now my n is not quite alone yet, so I need to add 1 to the both sides. You don't add it to the 729. It's like this is in parentheses, you tack it on the end. But if you put parentheses in it, you can put the whole thing in your calculator and you should get 7. I think what I'm going to do for the last question is here is this is what they're calling an interesting sum. So rather than me do it, I am going to assign it with the one question from a couple days ago on the Fibonacci sequence. I'm going to assign them together as an extra credit, so be on the lookout for that. All right, guys, well, it was amazing. It was fun. I'm sure you can't wait to hear from me again. Let me know if you need help. I can set up another video meeting if needed. All right, talk to you guys later.